Welcome to Inquisitive Kids. In this lesson, we will learn about the different rules to adding and subtracting fractional expressions. In our last video, we learned all about its multiplication and division. Now, here we're going to be exploring the two other operations, adding and subtracting. So, this isn't the only video we are doing on the addition and subtraction of fractional expressions. We will be actually having another part to this, and it will be coming up very soon. So if you don't want to miss out on that, be sure to hit the subscribe button as well as the notification bell. But that video will be all about the mixed operations of fractional expressions. So it will be putting our knowledge of multiplying, dividing, exponents, and our soon-to-be addition and subtraction skills all together. And again, all of these will be leading up to rational functions, something that we are yet to talk about. Anyways, here are our learning goals. Understand the rules of addition and subtraction of like fractional expressions. Perform addition and subtraction of like fractional expressions. Can convert unlike fractional expressions to like fractional expressions to add and subtract. So again, unlike fractions mean that it does not have the same denominator and therefore cannot be directly added or subtracted, and like fractions are fractions with the same denominator. And this is one of the big reasons why we put adding and subtracting after the multiplication and division of fractions, because adding and subtracting fractions is actually more complicated because you don't always have like denominators. So here is our introduction. What are the rules for the addition and subtraction of like fractions? And I also want you to calculate these 4 fraction questions. Now pause the video and go ahead. Well, for review, what are the rules? To add and subtract like fractions, the denominator remains unchanged and the numerators are added and subtracted. This is what we learned when we were just beginning to know how to add and subtract fractions. And in this case, like fractions, so that means that the denominator is already the same and we could just go ahead and add or subtract. So we keep the denominator and we do the operation with the numerators. And now using this rule, we can calculate these 4 questions. The first one becomes 1. The second one is negative 1/7. The third one is 1/2. And the fourth one is 2. In analogy to the addition and subtraction of like fractions, how can we calculate the following formulas? Pause the video and try to think about how you can calculate. Well, as you can see, these are all fractional expressions. And also you can see how they all have the same denominators. So that means that they are like fractional expressions. So you can have any predictions and maybe write it down, and then we will be going precisely into how to calculate the following expressions later in this lesson. So how do we add and subtract like fractional expressions? Let's find out. Adding and subtracting like fractional expressions. What do you think of when you observe the following formulas for addition and subtraction of fractions? Well, observing these two up here, again, we see that they are like fractions, and you keep the denominator while adding or subtracting the numerators. Same thing for fractional expressions. The answer to this would be 1 plus 2 over a, which is 3a. You keep the denominator while adding or subtracting the numerators. For the second one, you have 1 plus 2 over x minus 2. Here, the expression x minus 2 is the denominator. So the denominator is now not just one number, it's a whole expression. Anyways, since they are like fractions, they have the same denominators, you keep the denominator while adding or subtracting the numerators. And finally, for the last one, you also keep the denominator while adding or subtracting the numerator. So you have a minus 2 over x plus 1. Please compare the addition and subtraction of like fractions and think about how to add and subtract like fractional expressions. So how can you use the knowledge you already have of fractions and apply that to fractional expressions? Knowledge key point: adding and subtracting like fractional expressions. When we add and subtract like fractional expressions, we need to keep the denominator unchanged. Mathematically, we can write it as b over a plus or minus c over a is equal to b plus or minus c over a. Let's calculate. So the first one, we already have the solution out for you. The first problem is 3x squared over x plus y plus 3xy plus x plus y. So since they are already like fractional expressions, we can directly add them. The original equation is equal to 3x squared plus 3xy over x plus y. And then after we remove the common factors from the top, we have 3x times x plus y. And now we can reduce the fraction. So using the basic properties of fractional expressions to help us reduce the fraction, we have 3x as our final answer. And now I want you to use the same steps to solve the second problem. So here is something you might have noticed about this second problem. After you subtract the numerators and you keep the denominator, you end up with x squared minus y squared over x squared minus 2xy plus y squared. And you'll see that you can actually factor it and reduce this fractional expression using formulas. The top, you can apply the square difference formula and turn it into x plus y times x minus y, while on the denominator, you can use the perfect square formula and turn it into x minus y squared. And after canceling out x minus y on both the numerator and denominator, you have x plus y over x minus y. So notice, after adding and subtracting the numerators, the expression must be simplified. So it wouldn't work if you just had this as your final answer or if you just had this as your final answer. You have to make sure that all of the common factors have been canceled out. Example 2. Calculate x plus 3y over x squared minus y squared minus x plus 2y over x squared minus y squared and 2x minus 3y over x squared minus y squared. So again, using the same steps, pause the video and solve. Well, they are all like fractional expressions, which means we can directly add or subtract. This is what we will look like after adding and subtracting the numerators, and we keep the denominator. Simplified, we have 2x minus 2y over x squared minus y squared, but it doesn't end there. On the top, we can remove the common factor of 2, while on the bottom, we can use the square difference formula to turn it into x plus y times x minus y. Now, after canceling x minus y, we have 2 over x plus y. So this would be our final answer. But something that I want you to really pay attention to is when you are subtracting or adding the numerators, you need to remember to add parentheses around these. All right, or else it will become x plus 3y minus x plus 2y plus 2x minus 3y. But that's not what you want, because especially if you have a negative sign involved, a minus sign involved, remember, everything inside the parentheses have to change their sign. So if you wanted to take the parentheses out, you would have to have minus x minus 2y. But here's where a lot of students get it wrong. Instead of thinking of x plus 2y as a whole, they just give the x the minus sign while still adding the 2y. So that's a common mistake that people will make. So notice, the addition and subtraction of numerators is to add and subtract the entire numerator of each fraction. Adding these parentheses is essentially making you think of each of these numerators, each of these expressions on the top of these fractional expressions, as a whole. Again, this is where we are applying our holistic thinking. Here is example 3. Calculate this first expression. Again, this is a like fractional expression, so we can subtract. and we have 5x plus 3y minus 2x on the top. After combining like terms, we have 3x plus 3y over x squared minus y squared. And now, after factoring both the top and bottom polynomials, we have 3 times x plus y over x plus y times x minus y. We reduce the fraction into 3 over x minus y, and this is our final answer. Notice that you must be in simplest form. Your answer must be in simplest form in order for you to get it right. Now, pause the video to solve, and remember in order to get full credit for this question, you must reduce your fraction at the end. All right. So here is our solution. We combined all of the numerators, and we are sure to add the parentheses around each of the numerators. So as you can see here, there are 2 negative signs. And these negative signs or subtraction signs is why we must remember to add these parentheses, right? Because we're not just subtracting 3 squared b, we're subtracting this and the minus 5. So essentially we are adding 5. Think of the numerators as a whole and then add the parentheses. Again, this is emphasizing our holistic thinking. So after that, we can combine like terms, remove the parentheses, and we have a squared b over ab squared. And now we can reduce the fraction into a over b, since the common factor that can be cancelled out is ab. Here's an exercise. What does this expression equal? Well, for the first one, you should have gotten x squared minus 4 over x minus 2. And after factoring and reducing, you have x plus 2. For your next one, be sure to add the parentheses around each numerator, and then you can combine like terms, which gives you x over x plus 1 as your final answer for the second question. Now we are moving on to our next chapter, rules of signs of fractional expressions. Are the following equations valid? Explain why or why not. So as we can see, we have negative f over g is equal to negative f over g. And we also have f over negative g, and that is equal to negative f over g. So are these true? And if they are, why? If they are not, why not? Well, here's how one kid explained it. F plus g plus negative f over g is equal to f plus negative f over g, which is equal to 0g, which is equal to 0. So negative f over g is equal to negative f over g. The next one, negative f over g is equal to f over negative g. So f over negative g is equal to negative f over g. Example 3. Calculate the sum of these two fractions. Well, now you'll see that they're not like fractions anymore. But how can you turn them into like fractions? Here's one way you can do it. A lot of you might have tried to just cross multiply and then find the least common multiple for the denominators, but really that's unnecessary. Here's what you can do. You can turn it into AC over A minus B plus BC over negative A minus B. B minus A is really negative 1 times the difference of A and B. So that just equals AC over A minus B minus, see how the operation changed from plus to minus, BC over A minus B, and then now you can simplify, and your final answer should be C. But the key point is here, where you change the addition sign into the subtraction sign, but the sign of your denominator changed as well. Method summary. When the denominators of a fractional expression are opposite to each other, one of the denominators can be placed in parentheses with a negative sign to create like fractions. Class summary. Adding and subtracting like fractional expressions. Today we added and subtracted like fractional expressions. B over A plus or minus C over A is equal to B plus or minus C over A. We also talked about switching signs, where negative f over g is equal to negative f over g, and f over negative g is equal to negative f over g. Here are the 2 skills we learned today. Understand the rules of addition and subtraction of like fractional expressions and perform addition and subtraction of like fractional expressions. Can convert unlike fractional expressions to like fractional expressions to add and subtract. Thank you so much for watching through Inquisitive Kids, and we'll see you next time.